Hi guys, and this is the chapter 3 PowerPoint presentation, which covers the atoms and elements, the particles inside the atom, how the electrons are arranged around the nucleus, what isotopes means, and how they affect the nature of the elements, and which are metals and non-metals characteristics. We saw before that the atom means indivisible, and that actually is not real because we can break down an atom in different particles. The problem is that the atom is the smallest particle of matter that has the characteristic of the substance that we are talking about. For example, an atom of iron is the smallest particle that has the characteristics. Of course, we are not going to have an atom of iron shining because it's very small to be seen by the naked eye. But we cannot break them down. I mean, the atoms, we cannot break them down by chemical means. What does that mean? That we cannot break the atom unless we activate or we use nuclear forces, and we break the nucleus. If the nucleus is staying the same, the atom stays the same. It doesn't matter if the electrons are completely there or not, and we are going to see that in the next slides. But the first thing that we need to understand is that the atom is composed by neutrons and protons that are located in the nucleus of the atom, and they are going to be in the center of the atom, and surrounding them is going to be a cloud of electrons. We are going to use most likely the Bohr's model of the atom to understand certain behaviors, and for another properties, we are going to use the quantum model, which talks about orbitals that we are going to describe later. Even though we have lots and lots of compounds in the world, most likely they are made of only 92 elements that form those millions of compounds. Those 92 natural elements are located in the periodic table, and you can see them in yellow. The ones that are in red are man-made. That means that they do not exist in nature because they are very unstable. So we can produce them in laboratories, but they are going to break down in smaller substances, and that is what we call radioactivity, and we're going to see that later. The elements are represented by symbols. The symbols are made of one capital letter first, and then if there is a second letter, it has to be in lowercase. Most likely they are named after names that were made up very long time ago by the Greek or even in Latin. Like calcium, for example, that is the Latin name for potassium. When we went on discovering new elements, people who discovered those elements named them sometimes after the place that they were born. Like Marie Curie, when she discovered polonium, she called that polonium because she was from Poland. And Einsteinium is ES, and is in honor of Einstein. But we have californium, we have americium, and a lot of compounds that resemble some place or some name that we know. We say that the elements are located in the periodic table, and they are arranged in increasing number of protons, not increasing number of mass, increasing number of protons. That means that if I look at the element number 6, it's because it has 6 protons. When they are arranged in the periodic table, we can see columns and rows. The rows are what we call periods, and the columns are we call groups. They are also called families because the groups of elements, the vertical arrangement of elements, like for example fluorine, chlorine, bromine, and iodine in the one before the last column, are going to have similar properties, chemical properties, and that means that they are going to form like a family. The arrangement in the periodic table it's because of the properties and the number of protons, but also we can see that there is a zone that is red in the periodic table that is all the metals. Most of the elements that we have in nature are metallic. We are going to see the properties of metals and non-metals at the end of this presentation. The yellow part in the periodic table, and I mean the yellow boxes, those are what we call non-metals, and they also have certain properties that we are going to analyze. The stairs that you see in the middle, dividing the yellow zone from the red zone, the metals from the non-metals, are elements that sometimes behave like metals and sometimes behave as non-metals depending of the environment. And that is going to be what we call metalloids. So metalloids are elements that sometimes they act like or a metal or non-metal depending on the reaction that we have. You also see that in the periodic table we have different colors of letters. The letters, the black letters represent all the elements that are solid. So you can see that a majority of the elements are in the solid state. There are only two elements that are in blue. Those are the liquid ones, and that is bromine and mercury. And the other ones that have the red letter, those are because they are gases at room temperature. When we write down the formula of gases, if they are not noble gases, and noble gases are the last column in the periodic table, helium, neon, argon, and so on, we are going to have to present them as they appear in nature. And that means that they are going to appear in groups of two. So we are going to see in the next slide how to represent them. Okay, when we represent the elements that are circle here in the periodic table, like nitrogen, that means that they exist as diatomic elements. What does that mean? That if I need to write nitrogen, I'm going to put N2, or the oxygen, I'm going to put O2, or chlorine, I'm going to put Cl2. Now, if I need to represent helium or neon or argon, they are not circle. Even though they are gases, they are not circle. So I'm going to represent it as He or Ne for neon. The other ones, bromine and iodine, they are not gases. Actually, bromine is a liquid, but exists as diatomic molecules even in the liquid. So we are going to represent them as Br2 or I2 to represent bromine or iodine. These are not the only elements that we have in the periodic table that form molecules. These are diatomic molecules, but because they are formed by two elements alone. You need to know only the ones that are represented here with a circle, and we are going to make a rule so you can remember those. But you have to remember that there are more elements that are forming molecules, and those main elements are sulfur and phosphorus, the one that are just below that 7 that we can see. So the hydrogen molecule is represented like this. This is called a ball and stick because the balls represents the elements and the stick represents the bonding that we are going to see in the next chapter. But the sulfur molecule forms molecules of 4 atoms joined together, and the phosphorus molecules form molecules of 4 atoms joined together. At this level, you don't need to remember that, but be sure that you understand that we represent these ones and we write this when we write a formula as diatomic because they exist like that. Now, how can I remember which are the elements that are diatomic? We are going to make this rule. There are 7 elements that are diatomic, forming a number 7, beginning in the element number 7. Remember that we said that the atoms are arranged in increasing order of proton numbers or atomic numbers. So it's going to be 1, 2, 3, 4, 5, 6, and element 7, which is nitrogen. So beginning in the number 7, I'm going to form a 7. Be careful, do not use the noble gases when you try to form the 7. So it's 1, 2, 3, 4, 5, 6, and the 7th element is hydrogen, that is the here. This is just a mnemotechnic rule so you can remember how to represent them. We said that the periodic table is organized by groups of elements that have similar chemical properties, and that is the case of the groups that are numbered in different colors in the chart that you can see on the board. The first group number 1, is alkali metals, or the alkali metals react very vigorously inclusive with water. That's why they have to be kept underneath oil so they don't react, not even when they're moist in the air. The earth alkaline metals also have very characteristic properties. The halogens, which are the group 7 that we can see all the way to the right of the periodic table here. The group 7 are called the halogens. All the halogens are poisonous. That's why they are used, like chlorine or bromine or iodine. They are going to be used as disinfectants. Group 8 or group 0 is, or also group 18. We are going to see that when we see periodic table. They are called group 0 because they are not reactive. Those are what we call the noble gases or inert gases. You don't need to remember all these names. You need to remember the only ones that are in color, including number 9, 10, and 11, which are number 9 is the transition metals, and that is this zone here. Number 10, if you see the first element is lanthanum, and the first element in number 11 group is actinum. So the lanthanides are the elements that are after the lanthanum, and actinides are the ones that are after the actinum. These two elements are supposed to be here. Here is the lanthanum and here is the actinum. But because the periodic table wouldn't fit in a normal size paper, they took this part out and they put it underneath here. Okay, these are internal transition metals called too, but you don't need to know that. So number 1, alkali metals. Number 2, or group number 2, earth alkaline metals. Group number 7, halogens. 8, noble gases. You need to remember how to locate these elements.